Hi guys, my name is Dmytro. I'm software engineer with years of experience in Java. I am working for Intellias company. It is Ukrainian large company. Regarding me, I love to work on challenging tasks, distributed systems, prefer active sports like tennis and snowboarding. I like programming on Elixir Rust languages, despite that they are not popular languages for the time being. Yeah, and have couple of projects on these languages. So if you will be interested in my presentation, you can find it on my GitHub account with all examples. So plan for today. Today I would like to deep dive in to the network stack and show how client and server communicate among each other, how packets fall into the stack and where they are stored before the endpoint will process it. Also, I'd like to talk you guys about which network layers they are, which disadvantages are in TCP stack, and which alternatives we have to change TCP type, TCP protocol. Then we're gonna consider which types of sockets they are and what is Java NIO and how to use Java NIO for develop custom client and server applications. Let's get started, guys. First of all, queuing in the Linux network stack. What does it mean? Queues. The packet queues are a core component of any network stack or device. They allow for asynchronous models to communicate between each other. Increase what it what it provides. It provides increased performance and have the side effect of impacting latency. So I'm gonna show you some picture where I try to show you guys how this network stack is look like internally. First of all, you can find ENC. ENC, it is like network interface controller. A network interface controller, it is physical network card. It can be wire Ethernet or wireless, like Wi-Fi. Yeah, every Ethernet card contains drivers. Contains driver queue. Driver, you can find it here. Driver queue. It is like just simple ring buffers. Ring buffers is fixed size buffers that link it where in which head and tail is linked. So it provides fast access to the queue and take packets from the queue. So another part of this network stack is IP stack. IP stack contains sandwich with several protocols like IP protocol, TCP protocol, IP layer, TCP layer, and application layer. Let's consider deeply this driver queue. It is important. Driver queue does how it works. So when data is received from external world, network controller gets this data and put it to the driver queue. But controller doesn't put sensitive data to the queue. Data is put it to our native memory, and in driver queue we contain socket kernel buffer descriptors. It is references to this data where we can get this data. So if we take a look on socket contains read and write buffers, right, or input or output streams. It is references to this queue where we can get this data. Between IP stack and Ethernet card, Ethernet controller, we have pull-push strategy. What does it mean? Pull-push strategy, it is approach where one side push data to the queue and other side pull data from the queue. So IP stack and network controller, it is two asynchronously parts in our system. Yeah. So yeah, which problem we can have with this architecture? There are two problems. It is starvation and latency. Starvation, it is like when, for example, we have as these two parts is asynchronously, we can have situation when network controller is wakes and go to the queue and try to take some data to send it to external world. Yeah, and we can have situation where this queue will be empty. But when queue is empty, it is not starvation. It is normal situation. For example, if we don't have any information to send to external world, for example. Yeah, but starvation, it is like when network controller try to take some information, there is not information in the queue, network controller goes to sleep, and in this moment IP stack push to this driver queue some info. In this case, while a network controller is asleep, the data is stored in network and wait some time when a network controller is wakes to take this information and push it to external world. It is network. It is starvation disadvantage. How we can solve it? To solve it, we can get this queue with large size. In this case, so we need to get effect when some effect when driver queue in any time will have some information. In this case, when network controller try to take some information, he can get this information, and IP stack can put some information in any time too. So when we get this queue with a large size, we will get another disadvantage like latency. Latency, it is while a large queue is necessary for busy system to maintain high throughput. It has the downsides of allowing for the introduction of large amount latency. Yeah, so what does it mean? It means, for example, in this case, when queue is large, we will have, for example, different we can have data with different sizes. For example, this part of data have, for example, I don't know, 2 megabytes, and this the next data will have, for example, 1 byte. And in this case, if little information will be pushed to tail, and before this information there are a lot of data, the data with little size will be stay a long time. For example, the real example, it is yeah, for example, we have currently a video stream, and actually video or audio stream is split into little sizes and put it to queue. Yeah, it is real-time data. For example, in my machine, I can have some background task that processed some big information. In this case, little information will go to the external world with some latency. So how to get rid of latency? We need to have balance. It is regarding which task we solve, and we can configure this driver queue. Driver queue is implemented by provider that provide Ethernet controller. These queues configured we can configure in Linux configuration. Yeah, we just discussed it regarding latency. So let's go to the network layers. All we guys know about AZ model. Yeah, we have 7 layers. We learned it in university. So I would like to talk about it a little bit deeply. So first two layers, it is physical Ethernet layer or network layer. It contains physical layer and data link layer. Another third layer, it is IP layer. If we say go back to our picture, we see here IP stack. It is sandwiched with these layers. IP layer, it is IP protocols that have self-specification, and yeah, and on this layer we have packet with some information. So every protocol structure of every protocol looks like there are some headers, it is meta information, and some data, it is payload. Of course, it is not standard, but almost all protocol has some structure. So IP, we will take a look a little bit later on this structure of protocols, and I will say that IP protocol, it is like metadata information, and it has payload, and payload of IP protocol can be TCP protocol or UDP protocol, right? It depends of context. If we go to fourth layer, we can have here TCP and UDP protocols. TCP and UDP protocols also contain headers, metadata, and payload. Payload of TCP or UDP will be application protocols. It is from 5, 6, and 7 layers. For example, the main famous protocol for us, it is HTTP protocol. Yeah, so payload of TCP can be HTTP. Yeah, and if we take a look on HTTP also contains request line. For example, if we say about request, we have request line, some metadata like HTTP headers, and HTTP request can contain some body in context of HTTP. Yeah, it is payload that, for example, can contain JSON, XML, some binary, and so on and so on. There are a lot of protocols, SMTP, Telnet, DNS, SMTP, and so on and so on. Every protocol can work on some layer, transport layer, network layer, application layer, and so on and so on. For this, to get access for every layer, we have several types of sockets. We will be discussing socket types a little bit later. So, for example, a couple of words about network layer. On network layer, we know about IP addresses. Yes, we don't know anything about ports. On TCP layers, on transport layers, we can get information regarding source destination ports, and so on and so on. So every layer has some sensitive information. For example, if we say about routers that can route IP traffic, the router parse this IP protocol, get IP addresses, but they don't parse, they don't extract and parse data of this IP. They don't want to know about transport and application layer, and so on and so on. Just as example, ping, all we know, ping command. Yeah, ping command implement ICMP protocol and work on the IP layer. They don't know anything about TCP, and so on and so on. So the architecture and protocols of the TCP IP suite. Yeah, if we deep dive in our protocols that I mentioned it earlier, for example, we have network layer. It is third layer. On third layer works IP protocol. Yeah, and take a look on IP packet, how it's look like. So we had metadata. It is headers, yes, and data, as I said before. Payload of this data is data from L4, yeah, from transport layer. It can be TCP or UDP. Here we can find a structure of TCP packet. It is also there are metadata like headers and data. Yeah, in TCP we can see source port and destination port. In IP protocol we can see destination source address. It is IP addresses of endpoints. Also take a look on this header window or sliding window. We will discuss about this header a little bit later. It is important header for TCP. Yeah, the next slide will show us L4 and L5 to 6 layers. So this TCP packet from previous slide to be on the same page. Yeah, and payload of this data, we can see, for example, HTTP one request. We can request line, some headers, but there is no body. So, which disadvantage? Today I would say more about TCP, because Java can work only on TCP, only on transport layer. Yeah, go back to our layers. Java can access to transport layer. Java cannot access to network layer. If we need to access to network layer, we need to choose another language like C or Rust or something like this. Yeah, disadvantages of TCP protocol. There are some disadvantages of TCP protocol. First of all, hard to deploy updates to TCP because it's built into the operating system of our computers. So it means that TCP or transport layer implemented on the operating system. We can't choose implementation of TCP or UDP protocol, like, for example, dependency in Java. Yeah, if we would like to choose some, every operating system implement TCP stack protocol. In this case, we can't do some major updates of TCP, yeah, because it can be something broken, yeah, and fail. And we need, if we do some major change, we need to update all operating systems and routers and all devices in all the world. It is not real. Another problem is widespread hardware that uses TCP. Yeah, I just told about it, that there are a lot of devices that support TCP, and we can't update every time. Another problem, it is important problem, TCP had offline blocking. What does it mean? It means, for example, TCP has physical one channel, and we send data to this channel, and TCP guarantees to deliver these packets to the target. And let's consider some example. For example, we have some messenger like Microsoft Teams and Slack. And for example, I sent two messages. One message for user one and second message for user two. And my client opened one connection to the Microsoft Teams server, yeah, and sent to this server two messages. First to user one, second to user two. And as TCP is guarantees that this packet will be accessed on the target. For example, we have we have a long trip from me to user one and to user two, yeah, and let's consider that a message from user one is stuck or dropped in the middle of our trip. TCP guarantee that it need to retransmit this packet. In this case, and first and second message go to another trip and get our target, yeah. And in this case, we need to wait a message from user one to collect this package in collect this package and then resend to our users. TCP head of line blocking, yeah, it is blocked before first message doesn't access. Who can help us to solve these problems? So Google developed another protocol. It's called Quick. It was in 2015 years, as I exactly remember. So what does problem this Quick is solve? This Quick solve problem of TCP head of line blocking, deployed major updates, and so on and so on. Quick, it is not yet released. It is, as I remember, it is have draft specification, but Google products work on this protocol, like YouTube or Google Chrome, and so on. As most of products in Google is HTTP-based protocol, general purpose of this protocol is HTTP, but UDP is a general purpose transport protocol. So it means that we, based on this, it means that Quick can be changed. TCP can be changed to Quick protocol, and we can implement our custom we can implement our custom protocol like HTTP 3 and so on and so on. So what Quick is implemented based on UDP protocol. Why on UDP? Because UDP has TCP has some restrictions like guarantee to deliver messages and so on, but UDP no. So Quick get all properties from TCP, not all, but most of properties from TCP, implemented some improvements, and Quick always secure protocol. It support TLS 1.3, and yeah, based on this protocol, implemented HTTP 3 version that working on Quick protocol. HTTP 3 protocol, it is like HTTP 2. As you know, HTTP 2 protocol always developed but by Google, but it is implemented on TCP layer. Yeah, and famous protocols that use HTTP2, it is gRPC. Yeah, as I said, Quick is always secure. Quick offer both 0 RTT and 1 RTT handshakes. What does it mean? RTT, it is round trip time. Round trip time, it is important parameter. It is time. It is time from first package. For example, when we initiate connection, we send. If we, for example, if we take a look on TCP, we need to send sync command. Sync command means that client open connection to the server. Server should, if server received this sync, it should approve and send acknowledge and sync that server open connection to the client, and client should send acknowledge on previous package. So RTT is time when these three commands sends and connection is will be successful, and then data can be sent and received by these channels. So Quick offer as Quick working on UDP, it offer both 0 RTT and 1 RTT. What does it mean? It means that when Quick, when he firstly set connection to some host, it is cached connection, and for example, when we lost physical connection and then get this connection again, we just get from cache our connection and try to communicate. For example, it's real example when we switch between Wi-Fi's. Yes, when we has mobile phone and has some session in our local Wi-Fi and go to some restaurant and connect to another Wi-Fi, but our session with target cached and connection just get from cache and continue to communicate. Also Quick guarantee, also Quick support streams. If we remember that we discussed it, disadvantages of TCP when users send two messages. So Quick in one physical messages has logical streams, and every stream independent from each other. Yeah, and if one message from one stream stuck in something in the row, the other message, second message, can be delivered successful. Quick guarantee in order delivery of streams, it is like in TCP. TCP guarantee in order delivery of packets, but Quick guarantee in order delivery of streams. But data between streams can send asynchronously. Fast handshake, we discussed it. Quick is always using TLS. If we say about TCP not secured, and on application layer we have SSL protocol that can be create negotiation, set secure something like secure pipe, yeah, and in this secure pipe we can push and pull some application information like HTTP, Telnet, and so on and so on. So regarding network sockets, there are several types of sockets. You can find it here. It is datagram socket. It is sockets that can communicate through UDP protocol. A stream socket can communicate through TCP protocol. Row socket. If you remember, I told you guys that in Java we can access only for UDP and TCP. We can't access to application to IP layer. Yeah, if you need IP layer, we need to choose another type of socket like row socket. And that I would like to mention, row socket needs super user privileges to create in your system to create socket and communicate, because it's more secure. So one more thing regarding sockets, and byte ordering. There are when we exchange between client and server, in general there are different architecture of our processors, and our several processor can read bytes in different ordering. There are two types of ordering. It is big endian and little endian. In general, we read our byte information from right side to left side. This type of ordering is called little endian, but some microprocessors support big endian. It is when we read from left to right. Yeah, if we say about local machine, I mean, we have, for example, client and server on our local machine. It doesn't matter how we will read these bytes, but if we have our client and server on different machines, it can be confused and our data can be broken. So regarding Java NIO, what does mean Java NIO? Java NIO, in briefly, it is a Java core package that implemented new input-output communication between files and networking. There are one more packet. It is like JavaNet. In core, JavaNet contains socket, and it is blocked old library. What Java NIO provide? If you can see on this picture, this part of picture we discussed in the beginning of our meeting. Yeah, and sorry. Sorry, guys. Yes, and we know about this part, but how we can communicate through our application? So there is a socket. Socket, it is instrument that can send and receive data from network. We will say about Java NIO in context of networking. Yeah. So if we need create some connection, we create socket, and socket provides us some API to communicate through networking. Socket contains read and write buffers in Java in context of Java NIO buffers. Buffer, it is entity that it is structure that contains internally some byte array. There are a lot of types of buffers like char buffer, byte buffer, int buffer, and so on. But usually it is used byte buffer, raw data. So internally, byte buffer contains array with references to our memory. There are two implementations of byte buffer. It is heap byte buffer and direct byte buffer. If we need to allocate memory in heap, we use heap byte buffer. But sometimes we need to allocate memory in native memory. We don't want to allocate to heap. We want to allocate to native memory. In this case, we can use direct buffer. So socket contains read and write buffers, and also it is contains channel contain API to read data and write data and access to buffer. Java NIO implemented reactor pattern or dispatcher pattern. Yeah, it is pattern that can work in one thread, and it is register some events and handle these events. Take a look. Let's take a look on class diagram of reactor pattern. So we have some dispatcher, we have event handler interface. There are several implementations of these handlers. So Java, if you take a look on next diagram, Java NIO contains several states. It is like state machine. Accept state, write state, read state. And when we can register this state and subscribe on this state, and when we get some event, for example, if some data get from external world to our queue, operating system raise flag, and our selector choose right event. For example, if we have data to read data, we get read event. If we need to write data, we send data to write buffer and switch to write event. If we create some server, we bind on port, and first event that we would listen, it is accept new connections. If some client connection to our server, we get accept event, and that we will process it. How we can go to these states, it is depend from our context. For example, if we take a look on HTTP server, for example, HTTP server registered listen accept event. If HTTP client connect to our server, accept event is involved and invoked. And then we register our new connection. Then we couldn't, our server could not go to write state, because if we take a look on HTTP specification, told us that when HTTP client connect to the server, HTTP client should send request, and server should should provide response for this request. Server can first write something to this channel. So in context of HTTP server should go to read state and wait some information. When client sent HTTP request, he got it, process, and go to write state to write some HTTP response to the stream. How it's look like in the code? We have our reactor or polar. It is blocked class that work block thread, and selector. It is entity of Java NIO API, and select is a blocked method. Here we wait some events that we registered. Yes, and when some event we get, we can process it and call some handler. Here we, for example, register our TCP server we create server socket channel, bind to some host and port. We configure that our server is non-blocking. Java NIO support blocking and non-blocking modes. Yeah, we register accept event and register some handler accept, read and write. Here example how we can accept information. We need to check that our connection is valid. We check that selection key is acceptable, and then we can accept information and choose go to some state. To go to some state, we need to call register method and put some operation, read or write and something else. Read event handler, it's just simple too. Yeah, couple words about TCP data flow and window management. I would like to show you guys example on practice how it is work, but I think we don't have time to do it. Let me I will explain without example. So what does mean? To my mind, it is very important property of any system. It is so if you have experience with reactive system like WebFlux or Java RX or Flux and Mono, this approach, this pattern has some property like back pressure. Back pressure defines how to regulate the transmission of the stream stream elements. Yes, it is also supported in TCP data flow or window management. How we can do it? TCP protocol has headers and has some header like window sliding. If you remember, I show you show you here window header, and when a client and server connected, then client sent a packet like window size update and send how he can send how more information he can send, and then server send to the client how many he can receive information, and then he start to communicate between each other. And for example, what will happen if we so let's consider situation, for example, when client produce a lot of messages and our server is slow and can't process all of these messages. So when we get information from when we get data from the client, from this time we are responsible for this information, and if we process it very slow, we need to I don't know, we need to store it to queue, yes. And for example, if we store to queue, what will be if our server shut down by exception and so on? We can lose this information, but in this case, we need to move this queue to this. We need to distribute this queue, replicate, and so on and so on. We can and our design will be difficult. Yes, we can don't do it and use property of TCP data flow. And what we can do, we can, if our server is slow, we can just stop receiving messages from server. Not we don't need to broke connection. We just stop receiving messages and processing that we received. And then when we ready to get to receive new messages, we can just start to receive messages. This Java NIO allow us to manipulate of these properties, and in this case, when we stop receiving messages, responsible of messages from now is on the client, and client should choose what they will do with this data. Load balancing to other server, or stay in his in it internal queue, and so on and so on. But it is not us responsible. We stop, or for example, when we can if we if we can't process a big data, we can say server, we can say client, please show me information, a little part of information. Window size, it is header where we can manipulate of this information. So let me share a little bit example. So I wrote some simple TCP server that built on two ports. First port it is data port, and second port it is control port. And I will try to connect to this server with netcont TCP client. I connect it and say some information. Hey, what server is done? It is just uppercase message and sent back to my client. And in other terminal, I will connect to control channel, and control channel has two simple commands: stop read and start read. For example, if we would like to stop read, we send stop read command. We switch in Java NIO, we switch to state 0. We don't want to receive any information from the client. And for example, client sent information some, but doesn't get response. Because server doesn't want to receive these messages. Then we say server, please start read. And what we can see that we receive uppercase messages that we sent before. It is just a simple implementation. We can manipulate of this operation in Java NIO. And now I suggest you to see how we can manipulate this window flow. For our I will find some Json generator. I need just random data, and what I would like to do, I would like to stop read, and then I would like to get this data and send it to the server. If we go to Wireshark, what we can do just a second, see window parameter. It is window header that has some it is contain how many data I can send to the server. So I send. This window will be low, see 141, and then I tried to send new information, and my client doesn't there is no any reaction. And in TCP flow, we can see that server sent to client TCP 0 window. There is no, it means there is no space in our queue, yeah, because we don't read this message, and queue is full. And client time to time ping send packet 0 window probe and ping there is empty space in queue or no. And for example, for some time I start to read data, yeah, and what I can see that all data that I sent before processed by server, and here in our TCP, just a second, yeah, wait, in our TCP traffic, we can see that when we have empty space, server sent to the client, you can to the client that it can receive new messages, and it starts sequentially process inbound message from our queue. So, and currently we can send information. Yeah, it is just, to my mind, interesting example. So looks like that is all from my side. All references you can find in my presentation on GitHub. And now I'm ready to questions from you guys, if you have such. So when running these two classes in Eclipse, I only get the message received in the console, but not hello from the client and server. How do I get the two messages to appear in the console? Just a second, when running these two classes. Actually, I don't understand questions. You run my example from GitHub, or you implement your custom project. If you have troubles with your custom project, please share with me, and we will find why it is not working. If I next question. If I give the client code to a friend, what should they have in their socket? New, it is not local, right? 25,560. So what should be put there? Do I need to open a port on my router? If I give a client code to a friend, what? Just a second. It is not a local. Do I need to open port on my router? Yeah, you should open a port on your router, but if you it depends where is your friend. If you connect to one local router, yeah, you need just open a port. But if you in different, for example, cities, you need to have some public IP, and you need to provide this IP and port to our friend to connect to your server. How do you choose a specific port? Can I choose any, or where can I look for it? I choose any port, any access port. There are some utils that can scan accessible ports on your operating system. For example, let me netcat. I use netcat util, and netcat util have property like scan ports. Yes, you can configure it, scan all 3 ports and use one of them. But regarding ports, all protocols has some defined ports. Of course, it is not hard-coded, but preferable. For example, HTTP use 80 port HTTPS 443, and so on and so on. How the next questions? How do you choose? Yeah, I answered it on this question. Next question. Tell me, how do a high scalable client? I need to do lots of small HTTP requests at the same time for speed up. First of all, regarding HTTP, you need to enable keep alive feature for HTTP. What does it mean? It means that by default, when we how HTTP is work, client create a connection to the server, send request, server process this request and send response, and client close the connection. Yeah, and if your connection is secure, it means we use HTTPS protocol. We have extra negotiation. When we created connection, we need to create negotiation. There are approximately, I don't remember exactly, 13 commands that we need to exchange to get successful negotiation. And every time when we create connection, we spend some time. Yeah, and keep alive guarantee that when we create one-time connection, we HTTP client won't be close this connection, and you can put HTTP request to this connection. Yeah. Next question: where the TCP changes things? I also had this can be implemented via UDP. So how would that make a difference to the code? TCP changes things. TCP implemented by operating system. So there is a specification of TCP, and for example, we have Linux and macOS and Windows, and there are 3 different implementations of TCP stack of TCP protocol. Yeah. That I told before, it is one of the problem of TCP. We couldn't apply major changes for TCP because when we apply, we need to update all operating systems, and users should update this operating system to support some changes, and can be some these changes should be backward, should have backward compatibility, and so on and so on. And if we say about Quick Protocol. Quick Protocol implemented like standalone library. Yeah, it is external dependency. We can add it, for example, in Maven or Gradle dependency implementation of Quick and update version what we need. We don't need operating system. Yeah, and it is work on UDP more freely. Yeah. So regarding if we say about Quick, I forgot to mention it that there is no native implementation of Quick Protocol in Java. All implementations of Quick are in C or Rust languages. So there are family of libraries like Netty for Java. Yeah, I think you know guys about it, and it is implemented by Red Hat company. So Netty provided wrapper for Quick Protocol, and wrapper, I mean, it is use a native library that implemented on Rust languages. So thank you, guys. I think that you interested this presentation and have some new information about TCP. Thank you. Have a nice day. Bye.